Hello everyone, welcome to my YouTube channel, and today we are looking at this question here, which is known as to-sum. The problem gives us an array of integers and one integer which is known as the target, and we are supposed to return indices of two numbers such that if you add those two numbers you get the target. So for example, here we have an array which has 2, 7, 11, and 15. So we are supposed to get two numbers that add up to 9, and then we return their indices. And in this case, that's a 2 and 7. We are supposed to return 0 and 1. So the problem goes ahead and says it will have exactly one solution. So we know at least there will be two numbers in there, which will add up to the target. Then they are saying you may not use the same number twice. So what they are trying to mean here is that if you look at this example down here, we have 3, 2, and a 4, and our target is 6. So we cannot use 3 in this case twice, and we say, oh, we found 3, therefore 3 plus 3, it becomes 6. No, we cannot use the same element twice. But it's different for this case here because these are two elements. They are both 3, but they are two elements because they are located in two different locations. That's why we are able to return 0 and a 1. So how can you solve this problem? Let's say, for example, we had an array of 2, 5, 4, 7, and 8, and we are looking for two numbers to add to a 9. So I modified it a little bit so that it can fit in this explanation. So one way to solve it is trying to see if 2 plus 5 is equal to 9, or 2 plus 4 is equal to 9, 2 plus 7 is equal to 9, then we can return the answer. If we don't find it, then we can continue 5 plus 4, 5 plus 7, 5 plus 8. If no answer, you know what I mean. So this is going to be a brute force answer, and with that, it's going to give us ON squared. Let me show you a more efficient way. So let's see. Let's take the same numbers. So we are going to use memoization, where we will be looking at the numbers that we have seen and cache them somewhere so that we can always check and see what numbers have we seen. For example, if I'm at 2, I know that for me to get a 9, I need 2 plus 7. So in this case, the question I will ask myself is, have I seen a 7 before? But because we are on the first number, we have not seen a 7. Then we can cache the current number somewhere. So we are going to say 2 is located at index 0. Then we move on to the second number, which is a 4. So which number can we add to a 4 to get a 9? In this case, that number is 5. Have we seen 5 before? No. So therefore, we can still go ahead and cache our 4 at index 1. So the next number is 5. Which number can we add to a 5 to get a 9? In this case, it's a 4. Have we seen a 4 before? Yes. And it's located at index 1, and our 5 is also located at index 2. Therefore, we can now return these two indices because they are the indices where we have two numbers that can add up to our target 9. So let's jump in and see how to implement this approach using the code. So I'll start by declaring my map. I can call it map. It's going to contain the numbers that I've seen before. And then the next one I need is an array result that is going to store for me the two indices that I'm going to be looking for. Then I can do for int I equals to 0, I is less than nums dot length I plus plus. So this is where we will be testing to see if we have seen a number that we can add to our current number to get the target. So how I'm going to do that is by using an if statement, which says if our map dot keyset dot contains target minus nums into I. So let me just briefly talk about this statement here. So I am going into my map, into the keyset. If I have seen a number that is equivalent to our target minus the current number. So if our target is 9 and our current number is 2, then we are saying, have we seen a 7? If that number is there, I'm going to show you in a minute what we are going to do. But I will first like to go with the else part in case we don't find that number. So we are going to say map, we put our current number in there and its index. The next time we find a number that we can add to this current number to get the target, we can always find its index. Now, so what will happen if we find that we have actually seen this number before? Then what we will say is we will get our result and target minus nums I equals to our current index, because we are only interested with indices. I can break from here, and as you can see here, I've used one loop. I'm iterating through the array once, giving us the time complexity of O (n), and that's our goal. So the last thing I need to do here is actually return our result. So let's see if this works. Yes, this works, and let's see if I submit it. Looks like was accepted. So thank you guys. Please let me know on the comment what you think about my solution today. And if you like my video, please give me the thumbs up, and please don't forget to subscribe to my channel. See you in the next video.